Hi everyone. So this is a problem set that falls after worksheet number 4, and it's question 4 on this problem set. So the question looks like this, and you're supposed to balance using the oxidation number method. So let's start by assigning oxidation numbers here. I'm going to just switch colors. So copper here is by itself, it's an element, 0, and now we're going to go on to HNO3. Hydrogen is assigned +1. Oxygen is -2. There are 3 of them, so this is -6. This entire compound is neutral. So if we have +1 here, we have to figure out nitrogen's charge to add to hydrogens to make sure that it adds to, with this -6 to equal 0. So this has to be +5. +5 +1 is +6. With that -6, those two numbers add up to 0. So over here, the way you figure out the charges on an ionic compound is you go to your reference table and you figure out the charge on the polyatomic. Nitrate is -1. Even if you change the number of oxygens, so make nitrite or hyponitrite, for instance, the charge does not change. So if I have 2 of these at -1 and only 1 copper, and I know the total negative must equal the total positive, you did this last year in your nomenclature unit, this has to be +2. +2 with the total -2 would make for a neutral compound. Now I work with the inside here. These oxidation change states are not going to be any different than that one, but I'm just working through it so you see how I work through it. So there are 3 oxygens, each at -2, -6. So I think to myself, okay, I don't worry about this +1. I think, okay, nitrogen has to be such that it adds with the -6 to be -1. So it's got to be +5. +5, -6, -1. 2 times -1 is -2. That balances out that +2 to make a neutral compound. -2 here, 2 times +1 here, 2 times -2 here, -4, and then that must mean nitrogen is +4. So let's see how these are changing. So copper goes from 0 here to +2, so it's experiencing a change in oxidation state. Nitrogen here is +5, it's +5 here, and then it's +4 here. So nitrogen is changing over from this one to that one at +4. It doesn't change oxidation state here. So that tells me that all of this nitrogen must lead to some nitrogen being unchanged and some being changed. So we're going to balance the portion that is changed and then worry about figuring out the rest after. So copper is already balanced, 1 and 1. It's going from 0 to 2. It's becoming more positive. So that's 2 electrons that are lost, Leo. Nitrogen has +5 going to +4. There's only 1 nitrogen on each side already. So that's 1 electron, and it's gaining because it's becoming less positive. So this is a GR. Okay. So now we want to balance the electrons lost with the electrons gained, and we're going to do that by multiplying this by 2. That 2 transfers in front of these substances normally. So I'm going to put it here for sure, and that's going to balance the portion that's been reduced. I could put this 2 here, but I'm going to be mindful that I might have to change it. And the reason I know I might have to change it, it's not set in stone, is because I need to have a lot of nitrogen here in order to have some go here and some go there. So the 2 that I'm balancing is just the portion that's reduced. But I have some nitrogen being reduced and some not being reduced, not being affected. So I know that this has got to be actually bigger than the 2. The 2 just make sure that the nitrogen portion that's reduced is balanced, but not all of the nitrogen that I have. Okay, so what remains to be done, I'm going to just switch color here. Purple. So usually at this stage you balance the rest by inspection, and usually that means water. But I know this number has to be a bit bigger, so I'm going to end up having potentially to change it. You don't want to change this or this because you've already balanced the copper. You don't want to change this because that will balance the nitrogen that's been reduced. So you're going to have to play just around with this number and that number. So you know that if you add up all the nitrogen on this side, because We don't want to change the number in front of this substance. We already have the number there. We know that this side is secure in the number of nitrogens that it has. So there are 2 nitrogens here, 2 there, a total of 4 nitrogens. So this number right now is 2. It has to change to 4. 2 end up here, another 2 over there. So that's not typically something that would need to be done. It's just be wary of situations where the substance that's oxidized or reduced ends up in more than one place, because that's where sometimes you see these little subtle things that have to be paid attention to. If the nitrogen had been changed here and here, then typically in those problems, you wouldn't put the multiplier on that side. That side you do by inspection. This is a little different because it's changed. Some of it is changed and some of it is not. So the portion that's changed I can balance, and then I can get the rest by inspection afterwards. Okay, so now what remains to be done is just the water. You can usually start with oxygen or hydrogen, it doesn't matter, but I scan it and I think it's going to be easier to do the hydrogen because it's in fewer places. So 4H, so this has to be a 2 to get 4H. So the oxygen should now actually be balanced. 4 times 3 is 12. 2 times 3 on this side is 6, plus another 2, 7, 8, plus another 4 is 12. So they're actually balanced. It's a good idea to always make sure that your reactions balance for the number of atoms and for charge. So the total charge on this side, that's neutral is 0. The total charge on that side should be 0. Nothing here is charged, so that's less important in this instance, but I would always check my answers by making sure charge balances and atoms balance. Sometimes atoms balance, but the charge doesn't, so that can't be right. So this side is neutral, neutral, neutral. So the left side and the right side are both neutral. That's a good sign. All the atoms are the same number on each side, so I'm pretty confident that this is balanced. I'm going to check my answer key. It's a little hard to read there, but I'm pretty sure that that is correct. Okay, so that one's done. Thanks, guys.